Bismillahirrahmanirrahim. Dear students of 9C, Assalamu alaikum. I am your teacher Muhammad Ilyas. And dear students, this is our 7th interaction regarding chemistry for Cambridge. Our today's topic is identification of ions and gases, and this topic is from your book Chemistry for Cambridge, chapter number 1, and according to CIS syllabus, topic number 1.3. The objectives are as follows. The students will be able to understand the use of aqueous sodium hydroxide and aqueous ammonia to identify the following aqueous cations: aluminium, ammonium, calcium, chromium, copper, ferrous, ferric, and zinc. Dear students, secondly, we will focus on to identify the following anions, for example, the carbonate by addition of a dilute acid and subsequent use of lime water. Chloride ions by reaction of an aqueous solution with the nitric acid and aqueous silver nitrate. Iodide ions by reaction of an aqueous solution with nitric acid and aqueous silver nitrate or lead nitrate. Nitrate ions by reduction with aluminium and aqueous sodium hydroxide to ammonia and subsequent use of litmus paper. Sulfate ions by reaction of an aqueous solution with the nitric acid and aqueous barium nitrate, and sulfite by warming with dilute acids. Dear students, qualitative analysis is concerned with detecting the presence of certain species by carrying out simple tests and observing the outcomes. An ion is an atom or group of atoms which have some charge due to the loss or gain of electrons, and so the ions can be categorized into two types: the cations and anions. Cations are having positive charge due to loss of electrons, and anions carries negative charge due to gain of electrons. Dear students, identification of cations can be done in this way. Sodium hydroxide solution and aqueous ammonia can be used to demonstrate the presence of several different cations. Initially, a sample should be tested by adding few drops of reagent, mixing and observing any precipitate or other product. When this has been done, an excess of reagent should be added. Dear students, cations can be identified from the color of the precipitate, and the precipitate is going to be dissolved in the excess of alkali or not. Cations except hydrogen, sodium, potassium and ammonia give precipitates with these alkalis. Calcium identification test. When we add the aqueous sodium hydroxide in calcium solution, white precipitate of calcium hydroxide is formed, and these precipitates are not going to dissolve in excess of sodium hydroxide. And dear students, this is the identification of calcium, that its precipitates, its white precipitates are not going to dissolve in excess of sodium hydroxide. Calcium ions don't react with the aqueous ammonia. Ammonium identification test. When an ammonium compound is warmed with sodium hydroxide solution, ammonia gas is produced, and this has a characteristic pungent smell and turns a moist red litmus paper blue, because the ammonia gas is produced which is having which can convert the red litmus paper blue because of its pH. Its pH is alkaline. Iron identification test. When the iron is having valency 2, this is called the ferrous. Ferrous form green precipitate of ferrous hydroxide when it reacts with the sodium hydroxide, and these precipitates are insoluble in excess of sodium hydroxide. Dear students, on standing, The green ferrous hydroxide precipitates oxidize to form red-brown precipitates of ferric hydroxide. And ferrous hydroxide also form the green precipitate when react with the ammonia. And these precipitates are also insoluble when excess aqueous ammonia is used. Copper identification test. Copper forms the blue precipitates when react with the sodium hydroxide solution, because the copper hydroxide is formed which is having the color blue, and these precipitates are insoluble in excess of sodium hydroxide. Dear students, copper solution also form blue precipitates when react with the aqueous ammonia, and these precipitates are soluble in excess aqueous ammonia to give deep blue solution. Now we are moving towards zinc and iron identification test. Iron, when it is having the 3 valency, this is called ferric, and the ferric solution form the red-brown precipitates of ferric hydroxide when it reacts with the sodium hydroxide, and these precipitates are insoluble in excess of sodium hydroxide. Red-brown precipitates also form when the ferric solution is react with the aqueous ammonia, and these precipitates are also insoluble in excess of aqueous ammonia. Now we are focusing on the zinc. When zinc solution react with the sodium hydroxide solution, white precipitate of zinc hydroxide are formed, and these precipitates are soluble in excess of sodium hydroxide, and they give the colorless solution. And when the zinc solution is added with the aqueous ammonia, also form the white precipitates, and these white precipitates are soluble in excess of aqueous ammonia to give a colorless solution. This is how zinc we can identify the zinc both with the sodium hydroxide and aqueous ammonia. Now the aluminum identification test. Dear students, aluminium forms white precipitates of aluminum hydroxide with the sodium hydroxide when react with the sodium hydroxide, and these precipitates are soluble in excess of sodium hydroxide to give a colorless solution. Aluminum solution also form the white precipitates of aluminum hydroxide when it reacts with the aqueous ammonia, and these precipitates are insoluble in excess of aqueous ammonia. Dear students, to identify the difference between the zinc, calcium and aluminium, because both these three ions form the white precipitates with the sodium hydroxide and aqueous ammonia. When we add the sodium hydroxide to the solution, if white precipitates are formed and these precipitates are insoluble in excess of sodium hydroxide, this is indication of the presence of calcium ion. And if these white precipitates are going to soluble or dissolve in excess sodium hydroxide, so either zinc or aluminum may be present. Then we go for the difference between zinc and aluminum with the help of aqueous ammonia. When we add the aqueous ammonia, the both zinc and aluminum form the white precipitates, and if these white precipitates are going to soluble in excess of aqueous ammonia, then this is zinc, and if these white precipitates are going to insoluble in excess aqueous ammonia, then the aluminum is present. So this is the difference between these three: calcium, zinc and aluminum ions. Now dear students, we are going to identify the chromium. How we can identify the chromium? Chromium, when we add the sodium hydroxide solution in the chromium, green precipitate are formed which are going to dissolve in excess of sodium hydroxide. Dear students, these are the tests for the cations, and here's a summary for tests. You can get the idea of all the tests which we have done already. These tests for you. Ammonium produces a gas which turns the red litmus paper blue and no reaction with ammonia. Aluminium, white precipitate forms soluble in excess of sodium hydroxide, giving a colorless solution. White precipitate insoluble in excess of ammonia. Zinc, white precipitates soluble in excess, giving a colorless solution. White precipitate soluble in excess, giving a colorless solution with ammonia. Calcium, white precipitate insoluble in excess. No precipitate are formed with aqueous ammonia. Copper, light blue precipitate insoluble in excess of sodium hydroxide. Light blue precipitate soluble in excess, giving a dark blue solution with aqueous ammonia. Chromium, green precipitate soluble in excess, and gray-green precipitate insoluble in excess of aqueous ammonia. Ferrous, green precipitate insoluble in excess of sodium hydroxide, green precipitate insoluble in excess of aqueous ammonia. Iron, ferric, red-brown precipitate insoluble in excess of sodium hydroxide, and red-brown precipitate insoluble in excess of ammonia. Now, dear students, we are going